This is House Planning Help, episode 394. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build or retrofit. I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Hugh Franklin, Head of Operations at Aeroseal UK. We're exploring a slightly different approach to airtightness using a water-based low VOC polymer sealant, a mist to find the leaks and then seal them up. How does it work? We'll get to that in a few moments. We're not a politics podcast, nor am I about to share my political views, much as I'm tempted to from time to time. However, it can be quite overwhelming, can't it? If you feel the weight of the world on your shoulders and perhaps you feel there's nothing you can do, I might as well just switch off and check out. What I want to say to you, no, you can do a variety of things. In fact, what's that phrase? Is it the most common way people give up their power is by thinking they don't have any? We do. Some people have more than others, obviously. But what about things like how you spend your money? So that's one I wanted to highlight today. Are you spending your money with companies that share the same values as you do? For example, I know quite often we're driven to buy the cheapest of everything. I don't think that's always a great idea, and it can sometimes backfire. So I've been using a company called Ecotricity. I've probably told you about this on the podcast before. But what I like about them is that they invest their profits in new renewable generation. So that there's a good loop going on here. I get my electricity, but I think, well, the future, maybe more of it will be from renewable sources. And I like that. So look at what you're spending your money on. We all have to spend money on things, and quite often it's just on autopilot, isn't it? We did it years ago. Have things changed? So there's a thought I wanted to put to you. I'll give you one more example because I do this throughout my life, but I've just bought myself a Fairphone, which comes from the Netherlands, and who knows how it's going to work out. It might not be the phone for me, but I'm giving it a try and I like the philosophy behind it. So there's one way we can use our personal power, support those companies that you really love. Let's get to our featured interview with Hugh Franklin, Head of Operations at Aeroseal UK. We're talking airtightness today, and I must say a quick thank you to Mike Webb. So Mike's been on the podcast before. We'll link that into the show notes as well, the Seaton Beach development. But he's onto another project now, and he's been using AeroBarrier, and he's given me a tip off, so it's come onto our radar. And I thought, let's find out more. So I started by asking Hugh to tell me a little bit about his background.
So I started out actually as an archaeologist. So a very front end is essentially deconstructing old buildings slowly. That's where I really started. And that essentially moved into eco-construction. So looking at how we can learn from traditional housing in the UK and abroad and kind of really take those learnings, passive cooling, for example, solar shading, all the things, the way we deal with heat and cold from the last 2,000 years into modern housing. And that essentially evolved into working slightly more on scaling eco-construction and now into working on scaling airtightness. So that's my roundabout last 8 or so years of working in the trade. So yeah, that's how I've gotten to where we are now.
Do you want to explain a little bit about this product first of all?
Absolutely, yeah. So what we do is as Aeroseal UK, we have a product called AeroBarrier. Now, AeroBarrier is essentially designed to be a measured, dialable, so you can choose as a score, and a repeatable way to delivering air tightness as a product. So typically what we do is we do air tightness testing in UK new build homes and in some retrofits now, which is really great to see. But what we do with AeroBarrier is we pressurize the building, as in a standard air tightness test. And then under that pressure, all the gaps and cracks in a building are leaking out. Imagine a tiny pinhole has a small bit of air leaving, or a larger hole around a pipe might have a large amount of air leaving. We create a fog, a mist of a water-based low VOC sealant, our AeroBarrier sealant. And imagine that air is leaving that hole, whizzing out the hole like a puncture in a bicycle tyre. When you're putting it through the soapy water to find it, the sealant is drawn towards those leaks by the escaping air. It collides with itself and it seals it up. So it's not an expanding product, it's an accumulating product. There's no off-gassing or anything like that. And essentially, as those gaps get smaller and smaller and smaller, the building gets more airtight, but we can track it. So that score on the screen, which used to be a single point this is your airtightness test score now. At the end of a project or midway through, if you're doing a low energy build, it's always good to check. We can dial it down. We can reduce that score down to the specific requirement you need. So that's really what we're looking to do with scaling airtightness.
Are we talking about plastic? Is that what this is? Plastic in the air?
So it's an acrylic. It's an acrylic polymer. So exactly the same as a mastic sealant, essentially, or a liquid applied membrane. So the stuff you'd roll onto a building normally is what we'd use. It is 60 to 80% water, and we use an incredibly small amount. But yeah, essentially what it is, it's an atomized mastic. So that's really what we're putting into the air. And it's a synthetic and natural polymer. So yeah.
And is it dangerous when you're applying it that you've got to wear masks and make sure that the area for a certain amount of time is vacated?
Yeah. So essentially we control the space during the install, much like if you're doing an airtightness test, you don't want any other trades inside that building in case they're opening doors and things like that. We're outside the building for the time. The sealant seeks out the leaks itself. But when we're inside the building, we'd wear face masks or adequate protection in order to operate there. Once the sealing process is done, the building's able to be accessed again within 30 to 60 minutes because of the quantity or the lack of quantity we need to seal up these tiny holes. Instead of covering a whole wall in a sealant, like you would if you were manually applying, rolling something on or taping a sheet of membrane or plastic over an entire wall, we only need to seal the 2 or 3 tiny pinholes within that wall. So we use a very, very small amount of material in comparison to traditional applied systems, really.
And what happens to the plastics that go outside? If you're using pressurised installation technique, yeah, I understand that's going to build up gradually, but you're not going to catch all of it. So what about the microplastics outside?
So the way that works is on the internal face of this wall, imagine we're applying on the warm side of the insulation here. So on the inside of the building, we've got lots of different layers between the face where we're applying a sealant here and the outside of the building. We're going to have insulation, we're going to have the rest of a block, for example. That leakage path is not straight. So basically, as the sealant, it will catch and collide with itself throughout the wall, but it will start to build up at the thinnest point. So what we see is a very, very small amount of sealant leaving the structure. If any at all, it stays within that inner wall context. What we see leaving the building is the water vapour. As the sealant collides, the water is essentially coming out of the sealant as it creates its airtight seal, and then the water is what comes out, much like when you're plastering a building. It's quite muggy in there as the water comes out, exactly the same with our sealant. So we are essentially seeing the water leave the sealant as it starts to create seals.
And how durable is this?
Yeah, so we've tested this up to 5,000 pascals, so hurricane wind speeds, with 50 years of simulated and extended durability testing over 50 years there, with no breakages at those levels. So if you imagine normal building movement and airtightness, if you apply the sealant in those normal contexts, we are able to, say, have a 50 plus years of durability testing there. The key thing on the back of that is we control the environment in which it's installed. So as to say, we pressurise the building and we start to apply the aero barrier as a mist and a mist coat. What that means is, unlike when you might be doing some taping and the rain is lathering down or a wall is really wet and the tape doesn't quite stick properly, the tape might itself last for 50 years, but the environment in which it's applied is normally really quite tricky to manage. You know what it's like on a UK building site, the weather we've been having, basically all year this year, incredibly wet, lots of driving rain. We, by managing the internal space as we improve the airtightness, means that you get really, robust and repeatable results too.
Now, I'm assuming this isn't just a replacement for airtightness detailing, but what does it mean? It's not going to encourage us to be lazy.
Absolutely not. No, the key thing is that we have a real missing link between airtightness design and airtightness delivery. And we speak about this a lot, and that's a real part of our world, is the fact that you can buy airtightness material and you can try and install it as well as possible, but there's no real active feedback as you're installing it whether or not what you're doing is working, right? You don't put a piece of tape on the wall and go, I know I've reduced that leakage by 0.3 ACH or whatever you're trying to aim to for your airtightness scores. And that's the real missing link, is that when you install typical items, let's say insulation or glazing, it's really clear when you're missing a window. So it's a super easy thing for a site team or a project delivery team, either a self-builder or even large builders, to make sure that each stage of the process is managed effectively. It's a very visual game. Airtightness is the exact opposite of that. It's really hard to see. So that's where we want to come in, is help builders to see airtightness and see what's working and what isn't working. So if you've got a small gap where a window frame might meet its panel, or where a wall plate may meet, a roof may meet the top of a wall, you can run a whole piece of mastic or bead or membrane or tape across that whole run. And sometimes it's attached perfectly and sometimes it's not quite attached correctly. But it's really hard to tell. And so by Aerobarrier sealing only specific zones, after an install, we can walk around with the builder and say, this detail you did really well on, but this one here, there might be a small gap in the corner. Make sure next time you build, your teams pay good attention to this area here or this specific zone. And what that does is it provides iterative improvement. So when we work with larger builders or builders who are doing repeat work, or folks who want to move into eco, we often find that sometimes the first time you build it's like I say, like the rose-tinted spectacles of first-time eco building or low-energy building, and people go, oh, do you remember that project? It was an absolute nightmare. Well, no one really told you how to get better after it. You just remember the pain. So this way we can say, right, this is what went well, and this is where we can improve. And on sites of maybe 20 or 30 homes, or even 5 or 6, we see the plots getting a better airtightness before we arrive than the very first one. By the end of the project, they're starting better than when we did the very first unit. And that's a good show of, it encourages people to see light at the end of the tunnel, which is always a really hard thing with airtightness. So very roundabout way of saying, we are not a replacement for good workload. What we want to do is reward it. So saying, this is exactly what's gone well here. This needs a little bit of improvement. Send that back to design. See if you can find a simpler way to detail this particular problem or this thing the team's been finding difficult. Or really, make sure it's part of the QA, QC, that quality assurance, quality control element of part of that build program.
I'm imagining one of your challenges must be when all of this happens, because very rarely is a site perfect and ready to go, particularly on retrofit. But what do you have to say on this one?
Absolutely. I always say I want the building to look as much like a porcupine as possible. Post first fix is really when we want to come in. We need glass, ideally all the glazing to be fitted, and it's a pressurisable box. If I can put a fan on that door and pressurise it, and again, sometimes builders say they have that stage and they don't quite get there. It's not the end of the world, but we really want to be able to pressurise that building. And then to have as many of the services and utilities run through that building as humanly possible. Because we want it essentially to be its worst airtightness, but best time to make it better stage. So all the water, ideally, or the utility conduits coming in. If you're doing MVHR and ventilation, make sure the supply and the return for those two items are put through the building as well. And equally, membranes and any airtightness measures you're doing, from a manual perspective, also to be fitted and taped according to manufacturer spec. We'll then come in. We'll put Aerobarrier into the building and we'll drive it down to an airtightness score. And then as more layers get in, they should improve, but not be what you're relying on to get your airtightness down to your build requirement. We have a couple of low energy builders in the east of England particularly, and they've got more stringent, more council focus and citywide focus on building low energy in Cambridge, for example. We've actually found that when we've come to do Aerobarrier, after we've been in and 6 months down the line, as they add more layers and go further and further down, they're getting more and more airtight as more layers are installed into the building. So it's a kind of a get it to good or great, and then see that building get more airtight as we proceed.
Are there circumstances where it doesn't work or you're not going to come in?
The Aerobarrier system itself has a maximum install capacity of 10 millimetres. So a gap larger than 10 mil, which is 2 blue glazing packers, which is the way I describe everything as glazing packers, that's our maximum install width. Now, we always want to hybridise our work. So let's say you've got a really big hole. Aerobarrier will try and seal that, but it'll start to form almost a white halo around a hole that's quite large. But that means essentially like a heat-seeking missile. You can walk around the building either during or after an install and find those gaps and then fill them manually. So help to direct manual workload as well as manage the process of the scientific and measured way of improving airtightness with the Aerobarrier system. So that's really the blend. So yeah, not every scenario is Aerobarrier going to be the only solution you use, but it's a really good way, much like smoke pen testing with an airtightness kit, to find drafts. Essentially, you can use the way that the seals start to form airtight barriers as a way to direct manual work at the same time. So yeah, we definitely hybridise our approach as well.
And do you find yourself being called in when people have tried as hard as they can, and then they're just thinking, well, possibly this could push us over the line if we want to get to passive house standard. Maybe something's gone wrong or got covered up.
Yeah, I mean, so we get two principal kinds of projects, which is projects where clients have made the emotional investment in airtightness and making a low energy build. And they are, again, like Mike and all those teams there, and essentially looking to take that from good to great or great to really great. We want to install everything we've bought to the very best of our ability and then see what you can make it go to from there. Pip it just past the post. Essentially, that means we're being brought into a very organised process in most cases. Sometimes clients will feel that, hey, I can get this to airtight without aero barrier, and I'll call you in if I need you as a rescue at the back end. And that's always a slightly trickier scenario, but very achievable. And then, so that's the first kind. People who know about airtightness and think or believe that they're going to get a good score to start with. Then we get the what I call the Socratic lot, who are the ones who know that they don't know. And actually, they're my favourite kind of clients. The ones who say, we want to build better, and we really want to build a low energy home. And we know what we're doing in these 4 areas, but airtightness is the one thing where we'd really like to open up and come up with a perfect solution to complement and build you in. And they're coming from a real grassroots foundation. I typically find this to be the more engaged or the slightly more flexible and adapting group of low energy builders, the people who are going, I want to do this in a way that's net zero and scalable, that's actually really quite effective. And so they're the ones that go, hey, we want to achieve passive house, but we don't want to do it using the traditional methodologies. We want to use modern techniques. We want to use a combination of systems, or we want to, look at this in a more holistic way. So they're the ones where we get brought in at the design stage to talk about where that airtight line should be, working with other products, liquid applied membranes, mastics, tapes, whatever it might be. How can we design this from the ground up? Which is a lot of what we do with our large house builders, because they know that they don't have that low energy secret.
But, some of the challenge here is that you don't want to increase the airtightness without understanding the full system. So it's very, very important, unless we want to see lots of problems. We've had issues with the eco scheme where it was insulation, and it virtually all failed. Mm-hmm. So how do you make sure that the people that you're working with understand the physics and what's changing and what they need to do?
Absolutely. That's again, super crucial. And I think the thing about the eco scheme and the way the installations failed is none of it was measured. The measurement in the delivery is a real concern with those sorts of schemes. What is what we are doing to this building with insulation or doing specific elements going to do to its performance and operation? Now, the great thing about airtightness is that we measure it really well now. The UK is one of, if not the only, one of the very few places that requires 100% airtightness testing on all buildings that are new build domestic dwellings right now. And most commercials as well require an air test as well. So what that means is that we have quite a strong understanding around what different airtightness scores mean for ventilation systems and everything else. So the way that Part F, the ventilation element of the current building regs, interacts with airtightness, there's some really clear and quite hard and fast rules about when you deliver certain airtightness scores or when you include ventilation, what essentially are kind of the basketball hoops of distance that you can go for of airtightness you can deliver in that project. Now, the key thing with what, again, I think anyone who works in improving buildings generally will agree, is that the measurement aspect of that is really key. And so that's where what we can do and what we try to do at Aeroseal is deliver that measurability and the ability to stop. Not just to drive, to push this building to the absolute maximum, but by improving the building minute by minute, you can see when is the right time to stop improving the building based on the ventilation spec. So if you're saying builders go, I want to get this to a really good stage, but let's say a retrofit and they haven't got the ability to put a full MVHR system in, either a lived-in property or something along those lines, the ducting might be too difficult, or, the client's not willing to do it, it might be cost prohibitive. They go, but, just because I can't have the Rolls Royce of homes doesn't mean that you don't deserve a nice one. So saying, okay, well, why don't we optimize? Optimization is the key. And again, how we prevent issues with airtightness is by ensuring that we measure. And that's the only thing we can do, as an industry, is to make sure we understand what we're doing. And the post-occupancy aspect of this is super important as well. And that's actually how I think net zero or improving existing homes needs to get away from this funk of being seen as an issue or something that's dangerous or dark, deep waters is by saying, actually, you know what we're going to do? We're going to see how it works after we've done all these things, not just when we think it's going to work. So it's that reality versus that design.
When something is new, I am always wary and would rather go for the tried and tested route. So what's the history of this? How long has it been going for?
So the system was developed in the 90s, based in Scandinavia principally. Again, a country well rehearsed and known for its airtightness scores. Hey, when you live in cold areas, you feel the drafts more than almost anyone else does. So that's where the systems was first developed. And again, in North America, more stringently than anywhere else, airtight has been part of building regulations for a very long time. Or for any people who are interested in air testing, almost all the air testing equipment in the world is made in the US. It's the very first place that's been doing it. So essentially, the system initially was first the misapplied or atomized sealant has been around since, say, the 90s, early noughties. And this was then commercialized about 2010, 2012. So the tech's been there for a really long time. But then since 2012, Aeroseal has been focusing on ductwork, so leaky ducts. So if you're conditioning air, either cold, from aircon moving cold air, or moving warm air, depending on what climate you're in, if you have a poor fitment within that duct where they join, we know this with ventilation in the UK, it doesn't work very well. If you've got lots of kinks in your ductwork or things like that, all these bleed zones or zones of inefficiency ruin the effectiveness of that ventilation. So that's where the sealant was first developed and run. And that's been very successful globally. Then, about 6 to 8 years ago, Aeroseal went, hey, why don't we apply this to buildings as well? And so that's been the next iteration of the system. We've done about 300,000 homes globally with long-term testing in terms of all of our in-situ products as well. And we're looking to scale that all over from Canada, Australia, New Zealand, Saudi Arabia, US, Mexico. So all of a massive global presence. So we've got, again, tried and tested is more in scale and an operational side rather than the heritage or the long-term existing testing for our sealant too. So we've got all of that all going on over the next few years as well.
And have they returned to homes that have had this done a few years ago? I don't know how many examples you actually have.
Yeah, absolutely. So again, we do a post-occupancy testing as well. And again, we've got projects 2 years, 3 years down the line, both in the UK and abroad that have been gone back and assessed. The key thing as well is, much like all these things, it's not a statics. Every air test you would do is a snapshot in time. So in my home, for example, I'm perennially bad at sitting down, so always trying to change a thing or amend or edit a thing. Let's say we do an air tightness test halfway through a build. We know full well that building is going to have changes done to it before, when you do that halfway through air test, standard air tightness test, and the end of the project standard air tightness test. It'd be fairly naive of any of us to think that after that building's been signed off by building regulations that nothing's going to get changed in it. You might hang some pictures or adjust some doors or windows or, maybe even fit a new sink. So you've got all these little tweaks and changes over the course of the building that essentially could impact the air tightness as well. But long story short, the sealant itself is not the thing that's going to be degrading. It's not the thing that's going to be losing its ability. It's permanently flexible and it stays in situ quite effectively there. So we've tested homes. They've maintained air tightness in our testing as well, doing cyclical testing up to 800 pascals. So that's strong gusts of wind. We see an almost 1 to 2% degrading over 25 years. So very strong long-term testing, and we've got BBA currently doing ongoing assessment as well. So all of those tried and tested systems is what we're doing.
And when I think about air tightness, also from first principles, simplicity to begin with in the building so that you haven't got too many places to go wrong. Are there any other things that you advise from the outset?
Yeah, actually, it's really, again, so first principles wise it's almost like know your limits as well. So the issue we have is actually when we want to define something, and again, back to the whole measurability conversation, but defining who does what is the absolute crucial thing I find in air tightness. And I often get asked, what is the most airtight build type? It's the one you care about. I don't mind whether it's masonry. I don't mind whether it's timber frame or ICF or any of these different things. It's the buildings you really make an invested choice to improve it. They're the ones you get the best results in. So as I say, we work with builders specifically, but also the self-build groups to say, this is that second group, that build from the ground up. What should I use where and what should I use when? So you say, get the building to a really airtight stage, try your best, and simply look for gaps that are over 5mm. If you're looking for gaps that are 1 glazing packer, anything that looks like it could move air on the inside of a building that's larger than this blue packer, you need to use manual systems to do. And that can be done by your mason, it can be done by your window fitters, whoever's doing these specific elements. Choose a tolerance and stick to it. Then what happens is you change gear and use a different system to get it from that good stage to that great stage. That is the way that I drive for simplicity with builders, is not go crazy and try to do everything everywhere always. It's create a plan, stick to specific elements, do those bits well, and then essentially allow an additional or secondary trade to come in to do more work to get it to a different stage. Because the people that impact air tightness the most are often the plumbers and the electricians and the ventilation fitters. And these are not people who have been trained or taught specific air tightness in any real format. And again, we have all the Passive House tradespeople courses, which are really, really good. But the issue is that we can't get every builder in the country onto those. So we need to find a way to take the key learnings from these tradespeople courses and make them into a format that dovetails nicely into existing work. So they're saying, by the way, completely retrain away from being a plumber to being an air tightness / plumber. It's actually be a plumber and make sure that any pipes you fit, there's no more than 5mm around your pipes. Simple. Any plumber can do that. If you're putting a 50mm pipe through a wall, don't use an enormous coring drill to get through for a tiny little water pipe. All those little bits and bobs mean that you can essentially set an upper band. And setting the worst case, but also expectation I think, is the best way to ensure that we get consistent air tightness. Because it's not really fair to ask a normal plumber who's on a price to say, oh, by the way, can you go enormously outside of your existing scope to make sure that this thing that actually really isn't your responsibility, it's not part of your work package, and that's really important. It's not part of their work package to deliver. I want you to spend time, effort, and resource to do. But actually, if you say, can you just make sure that you don't make holes or cut things in this layer, or when you're chasing cables in, make sure you do it in XYZ format, then it means that when you need to get it to a low energy level, it's really, really easy to do so.
So you must have a sense as well of the quantity of material that is going into the building. When it goes through this process of turning into the mist, what quantities might you have for, say, a 200 square metre floor area home? What are you thinking?
In a standard good to great, we'd be probably using a maximum of 10 litres. So that's 2 paint pots of sealant.
And this is always the argument of all the energy that you will save over the coming years.
It's an unbelievably low barrier to entry, and we have EPDs, the environmental product declaration elements, to basically show that the improvement scale, and I must give massive credit to Sally at Warm Consulting, who's one of the creme de menthe of low energy consultancy as well in the UK. She's got a fantastic thing about showing actually the uplift, the bang for buck essentially of improving air tightness is quite a strong case for energy. And so we use a very small amount of sealant to seal quite large buildings in most cases, just because you're only trying to seal a small amount of, a very few number of leaks that actually contribute to a large amount of energy loss.
And that's from the group that try their hardest. So how would that compare if you were doing the same thing for the other group?
The other group, the fifth column of construction, of low energy construction in the UK, which is the hard as nails, the quantity surveyors. I tell you who my favourite people to have conversations are with is the quantity surveyors, because being eco-friendly inherently saves you money. Wasting less is cheap. It's a wonderful way to not spend. So myself and in large numbers of the Passive House community, more than most, drive it for quality and a real obligation and desire to do better and build better. The way I convince the other group is they waste less. It's cheaper to build low energy draft-free houses.
Good argument.
And they go, fantastic. Okay, so you actually only need to use 10 litres of your sealant or 5 litres for doing our 10,000 90 square metre homes, or our apartment sets, or our low energy. We've seen with Barratt in London, for example, their low energy building standards and all those things. So I don't have to use 5 tubs or all these tubes of mastic, which is expensive because we use so much of the stuff. I only need to use half a pot. Absolutely, great. And the only difference is how you apply it. That's a very compelling argument for a price-sensitive audience.
While we're on that topic then, how do you budget for this?
So the best way to budget for this is by square metres of floor area. So if you're building your own home and it's a one-off project, I'm looking about £12.50 per square metre. So you're building a 100 square metre home, you're coming about £1,250. Building 200, obviously double that there. In terms of return on investment, that's a really important part of what we do. It's 3 to 5 years is what we typically see from a standard building regulations home to a low energy home. The amount of energy you save, and this excludes comfort and everything else, labour, materials, all the other stuff that would go to delivering that 0.6 score from a 5. And that's really what we can do, or what, when you apply air tightness, effectively can be done. Building regs, if you compare the UK pound for pound, or England and Wales specifically pound for pound, with a large number of other countries around the world, the raw spec is actually quite strong. If you look at what a low energy building standard could be, or a net zero building standard is around the world, and compare that to UK minimum requirements, there's not a massive jump between the two anymore. There used to be a huge chasm, but now it's much tighter. But the big area we haven't improved for a decade is our air tightness. Air tightness hasn't improved since 2015. It's a massive area of opportunity for a lot of builders. That's a big thing for us, is the cost aspect for self-builds is huge. A massive opportunity for saving there.
And although some of the spec is good and probably getting better for building regs, it's the execution. That's where some of our challenges are, and how you monitor that.
Absolutely. It's execution, and this is the thing, is that we're really good at designing net zero buildings. We're really good. We're one of the world leading countries for designing them, and we're one of the potentially poorest at delivering them. And this is the thing, is that why on earth is there this massive gap? Are we buying triple glazed windows and installing single glazed? It can't be that. Are we buying a wall that's 350 mil thick and installing one that's 150 mil thick? It can't be that. Well, where else are we getting a design score that essentially is really not representative of its delivery or in-use spec? And that's essentially that air tightness we find, or we feel at least. And again, a lot of if you look at any risk register for that cost sensitive group of builders out there, the bit that they get most panicky about, the fear bit, is the air tightness. How do we make this something we can do again 100 times, 1,000 times? And if that's what your hard as nails, cost driven builders are thinking about, if we want to get through to them and really move the needle on delivering net zero, and making that barrier to entry lower, and really spreading the good word of doing what we do, then we have to find a way to make it cheaper. That's the thing. Once it's cheap, everyone will do it.
Let's talk a bit about Mike Webb and his project. So how might the process work? He comes to you, what happens next?
Yeah, so essentially Mike came to us with a very top level conversation about his project, and that's really all we need. You can often tell by a phone call, which is why I love phone calls, how invested a client is in what they want to achieve. And he came to us with a background of building a low energy project in the southwest, and saying, hey, I want to do this again. It's an existing building that's having a deep renovation done to it, improved glazing, insulation, everything else. And we want to make sure that we don't drop the ball on air tightness. So the next question we ask is, what are your current plans? What's your thought process? And all those bits there, talking about, as I say, the detailing understanding of, there's only so many ways you can skin a cat with air tightness. As you've mentioned, simplicity is key. If I get a 50-page drawing pack of air tightness detailing, I get very nervous very, very quickly, because it means essentially that someone is trying to create bespoke for every element of a project, whereas the best thing to do is provide good, strong guidelines. So Mike and the team had really a good understanding, saying, hey, we're going to take these areas, we're going to do a parge coat here, we're going to do X, Y, Z, we're going to be insulating, we're going to be taping that insulation. All sounds fantastic. The next question is, where do you want to be? What's the ambition at the end of this project? He said, well, we're going NFIT, but we'd really like to be lower than that. And so essentially what we set is, as a business, is tolerances. As I mentioned earlier, say, right, if you want to build to building regulations, make sure your gaps are less than 10 mil, that double glazing packer. If you want to be building with ventilation down to ACB or NFIT standards, that one, we change metric halfway through here with air tightness, but down to a really good score, 1.5, you're putting ventilation into that project. MVHR systems, we ask for that tolerance to be reduced to 5 mil. And then at Passive House, we ask you to really be focusing, because what we don't want is people to us to deliver an airtightness score, that builder today, I'm at 0.3, 0.2, which we do often deliver halfway through a build, and then they take their eye off the ball. So you need, once we've left the building, it's sort of like a toddler walking, and that's no disrespect to the builder. It's like going, please don't fall over. We really want these things to get to maintain and improve their scores. So it's all about that management ongoing. So when someone says to me, I want the best home I can get, and I really want Passive House, Mike was in that very same boat, said, great, let's have a chat. And just came onto the building with ideally no finished floors down, because the sealant settles on horizontal surfaces. Gravity is the enemy when you deal with fog. Vertical surfaces we're completely fine with. So if you imagine a window, at least with good modern windows, or even good existing windows, you won't see any air movement through the glass. The glass itself is airtight. It's how the frame interacts with the glass and how the window interacts with the building. That's where the leakage happens. So essentially, the sealant will only be drawn to those areas, whereas the horizontal surfaces, if they are at screed level or first fix, as we said, with all the cables running through, that's perfect for us. So we jumped on, and I think we had 3 of the units on site. I think there were 4 there. I can't remember quite how many, but all bar one, we aero-barriered, and they were all ideal stage, first fix stage. And then Mike's business partner said, hey, we've literally just finished on the end there, and I think we got 0.7 or 0.8. Would you be okay to come in and do that one as well? So we did a bit of horse trading on the ground, and then we said, yeah, we can get that sorted. So as the other 3 were going, as we were sealing them and getting them more airtight, that one had finished flooring down. So we basically protected that with Corex or, covered it over, exactly as if you were doing painting or decorating, which is what they were just about to come to. And so that was all almost ready for us to rock and roll, covered the kitchen worktops, things like that. That level of cover is sufficient for aero barrier, much like an umbrella in heavy weather. The zone underneath the covering is safe. You hold the umbrella above you, the rain is coming down, you're dry underneath it. It's exactly the same when we cover surfaces. So we cover a worktop, leave a little bit of an overhang, and all your cabinets are all fine because there's no leakage through the cabinet. The leakage is going out of the building. So we don't have to cover all those internal, vertical surfaces, as we've said. So we then sealed that one down too. I think we delivered every single one of those to below Passive House. And yeah, again, over the moon. So a really great, almost an ideal client to work with, to be quite honest. Engaged, knowledgeable enough, not too much to be dangerous, but enough to know with a delivery aspect in mind, but open-minded enough to go, how can I get better? Not coming in saying, I know how to do airtightness. It's saying, I know how to do airtightness right now. How can I get better at doing airtightness? Which is the same approach we want to take. I learned a lot from Mike. We learn a lot from our clients. And again, we want to pass that knowledge on as well. So that's those kind of 3 things, which is invested, engaged, and really willing to work with, not just be either talked down to or talk down to us, which is really important as well. So working with and cooperation.
And this sounds like a key stage, but any tips on how to maintain that airtightness once it's created? Because first fix, you have still got quite a bit to come of the project.
Absolutely. And I think the main thing there is it's more not taking one's eye off the ball. So we're talking about low energy and installing at first fix, and that's essentially when an interim airtightness test for a Passive House project would come on. Now, airtightness generally in low energy buildings can be seen as a fighting retreat. Drive the thing to its absolute best and make sure that as you proceed, you don't let anything slip past you. Even for, let's take 3 groups. So you've got your client, let's say a self-builder or someone who's doing a low energy home and is potentially involved to a degree. When you get that first air tightness score, that is not your final, nor is your final air tightness score when the building is complete. You will never have a final air tightness score for this project. So if you want to maintain an air tightness of the project, you have to be incredibly aware of every time you think about doing something that goes through a wall, where it might be cold outside and warm inside, any format of those, that movement of a cable or making a change to a building, putting a pipe through, all of those things need to be readdressed and confirmed and made good. So that's from the client side, essentially, is that when you get an air tightness test, even without us in a Passive House project, that you're at 0.3, that's not your final air tightness score. So making sure that you're like, hooray, I've had sort of like a mock, I guess. Like you do GCSEs or A-levels and you go, I've done my mock exam and I've come in and I've gotten, my teacher thinks I'll do well. So that's the first bit. From a project manager side, so let's say your first foray or maybe your second foray after a potentially a false start one time on doing low energy, how to maintain that airtightness going forwards is honestly making sure that your subcontractors and the guys who are working on site understand the importance of what they're doing. Everyone is part of the big machine that makes this thing turn from ground to a house. So once you get that airtightness as well, it's, hey guys, as you are maybe moving cables or moving things around there, make sure that if you need to yank or you need a bit more cable here, do it in a managed, organized way. Don't start ripping, don't start cutting. A classic one for us is when we have a dropped ceiling, a suspended ceiling. So we have a membrane and we might have a batten, so some timbers to bring that plasterboard down. Super common in bungalows or single story areas where you're having spotlights or recessed lighting pushed into that space. And typically your recessed lighting is quite deep, it's quite thick. And 9 times out of 10, I'm sorry to say that there's not enough batten depth left between that membrane and that plasterboard to allow for the recessed lighting, your spotlight, to fit. Now, it's not an electrician's fault that that's happened, but they're the ones who are left holding the baby, essentially. And what can happen is sometimes they'll snip it, the membrane, in order to fit the light to fit back correctly. Horrible airtightness detail. No one's really watching that because the plasterers are done, so they feel they haven't made any holes. The membrane fitters say we haven't done any holes, and the electrician's going, well, it was all airtight at first fix, and that can change the scores radically. So it's all around that almost unbreakable layer in that building. I'm not saying don't break it, but saying if you have to go through this layer, make sure someone knows why and how to resolve. That's the crucial bit. Don't do anything accidentally. Or
No blame.
No blame. No blame is so important. And it's also, there's no such thing as a mistake, right? There's only doing something and telling nobody. That's the absolute ultimate thing. So there's a couple of really clear examples of doing those. Same with back boxes for your sockets on walls, or same for when you bring a soil pipe or a waste pipe in. Exactly the same thing. You might get it halfway, you might have to change size or drop it into a bath. What all these little things that happen after a project is rolling again. And it's just making sure that as you make those changes or any of those bits, that builders are aware that no one's gonna bite your head off. That's super important at each stage of this project. Clients don't get grumpy. Project managers make sure everyone's engaged the whole way through. And subcontractors make sure that you're not doing something in isolation. That's really the important thing. It's collaboration and community, really.
Well, let's wrap it up here. Is there a final thoughts?
I think the thing is that for me, I really consider airtightness to be not rocket science. I think right now, unlike all other aspects of construction, it's sort of seen as this black magic dark art. We need to get the airtightness guru in wearing a druid's hat and dowsing for water. Fundamentally, we're never gonna convince and convert. I get very evangelical. The wider building community, which is the way that we get low energy housing to the mass market, is by bringing people with us, not isolating them from us. We're never going to get them over if we don't show a really clear path to get from where they are now to where we would like them to be, and to make that path cheaper and faster and more effective. They're the key 3 things. So if we can do those bits there, that's what I see airtightness as, a potential opportunity to really show builders that low energy building doesn't have to be this dark art, or doesn't have to be something to be afraid or fearful or push back against, but actually a thing that we can strive to. And equally, low energy building doesn't also have to be unscalable. I think that's the crucial thing as well, is that we all want everyone in the UK to live in nice housing, not just those who can afford it or those who are emotionally invested in delivering it, but actually getting it out to every person, every home, as much as possible, really. So yeah, that's where we see us hopefully helping.
Another tool in the armoury.
Absolutely. Yeah, thank you so much.
Head online to take a look at the show notes that accompany this session, houseplanninghelp.com/394. We've got a summary waiting for you. See a few photos of it in action. If you've got a comment or you'd like to get interactive, we'll give you social media links to Aeroseal UK, all at houseplanninghelp.com/394. Finally today, I thought I'd highlight it again that we have now closed the hub. Oh, it was fun to run the hub. I miss my beginning of the week calls. For years now, I've started every week having a chat with the hub members, and that's not happening anymore. But there you go. We have moved on. And currently, instead of running the hub, I am thinking, how in the world can I get onto another construction project? I might be mulling that for a while, but that's on my plate. But just a quick reminder that we did close the hub in the last few weeks. So if you haven't heard that message yet, go back an episode and I'll explain a bit more. Thanks for listening today. The House Planning Help podcast is produced by Regen Media, content that matters.